TX73 Excavator 3D Guidance System Calibration Instructions. 1. Preparing the calibration tools. Before starting the calibration, please prepare tools such as a plumb bob, a 10-meter tape measure, a level, a total station, base station, and a TK tool. Calibration preparation. 2.1 Boot up the system. Turn on the system switch. The software will start automatically after booting up. 2.1 Software registration. Open the app and tap the logo in the upper left corner. Select offline code, choose the imported registration file, tap import, and then tap register to complete the process. 2.3 Software upgrade. Click the upgrade button to perform an online upgrade. Please make sure the tablet is connected to the internet. 3. Calibration. 3.1 Calibration area selection. Park the excavator on a flat, open area, ensuring there is enough space for the body to rotate and the boom and stick can extend fully. 3.2 Enter the calibration menu. Click on Menu, Config, Admin Mode, Password, Magnob 20 to 5. The calibration menu will appear. Click on Calibration, click on the calibration wizard, and enter the machine setup interface. Confirm and select the type of configuration, whether there is a quick release, whether there is a tilt rotator, the installation size for sensors, and the attachment sensor installation position, then click Next. 3.3 Sensor configuration. Choose the corresponding SN based on the sensor installation location. After the configuration is complete, click Next. 3.4 Mechanical measurement and calibration. 3.4.1 Body sensor calibration. Before starting this step, please note that the roll and pitch angles of the body sensor should remain within 2. Please note that in this step only the vehicle body should be rotated. No other parts of the machine should be moved while performing this step. Move the excavator so that it is possible to do a full 360-degree turn without moving any other parts. Rotate the excavator 180 degrees. Then remain still. Continue to rotate 180 in the same direction. Then remain still. After the calibration is complete, click Next to enter the boom sensor calibration interface. 3.4.2 Boom sensor calibration. Set up the total station in the middle position of the boom and level and center it. Calibrating the boom sensor. Adjust the boom until the connecting line S1 is leveled horizontally. Then click the Calibrate button. Stick sensor calibration steps. Move the stick until the corresponding line S3 is leveled vertically, then click the Calibration button. Dog bone sensor calibration steps. Move the bucket until the dog bone is leveled horizontally, and then click the Calibration button. After the calibration is complete, click Next to enter the size measurement interface. 3.5 Size measurement. Note, when measuring the dimensions presented in this interface, try to be as precise as possible, aiming for millimeter level accuracy. Either tape measure or total station can be used to collect the measurements. Use a tape measure to measure the distance S1 between pivot axis of boom and body and pivot axis of boom and stick. Measure the distance S3 between both pivot axes of the stick. Measure the connecting rod size L1. Measure the connecting rod size L2. Measure the connecting rod size L3. Measure the connecting rod size L4. Following measurements do not need to be accurate to the millimeter. These are used to scale the model of the machine on the screen. Accuracy of 10 centimeters is okay. Measure the distance H from the main antenna to the ground. Measure the width of the track, A. Measure the length of the track, B. After completing the measurements, input the measured dimensions into the software and click Next to enter the rocker diagonal menu. 3.6 Rocker diagonal. Open the bucket fully to the limit, measure the distance L5 and import it into the software, then click the Calculate button. Adjust the bucket to approximately the center position, measure the distance of L5 and import it into the software, then click the Calculate button. Close the bucket fully to the limit, measure the distance of L5 and import it into the software, then click the Calculate button. Note, if you cannot pass this step, please recalibrate the stick and dog bone sensors and recheck the dimensions L1, L4. Recheck the connecting rods measurements. Click Next to enter the interface of arm checking. 3.7 Arm checking. Open the bucket to the limit. Adjust the stick to almost vertical. Place the blade to the ground. Measure the distance S5. Input it into the software and click the check button. Note, if you cannot proceed through this step, please recalibrate the boom sensor and make sure the dimensions S1 and S3 are correct. Click Next to enter the bucket configuration interface. 3.8 Bucket configuration. Click Create button to create a new bucket. Enter the bucket name and select the corresponding bucket type. Measure the distance S1 from the stick pin pico axis of stick and bucket down to the bucket blade edge. Measure the width of the excavator bucket W1. Note that these 2 points are the reference points used for M1 and M2 calibration. Input S1 and W1 in sequence. M calculation. Place the plumb line at the stick pin and adjust the bucket so that stick pin and bucket blade edge line up vertically. Then click the M calculation button. Angle B calculation. Place the level on the bottom of the excavator bucket and adjust the bucket so that the bubble in the level is centered and the bucket bottom is leveled horizontally. Then click the B calculation button. Click Save. Select the excavator bucket and apply. Click Next to enter the antenna calibration interface. 3.9 Antenna calibration. Please note that the OTK in this step needs to use the same coordinate system as TX73. Please check the parameters within the coordinate system. Please note that rotation of the vehicle body is not allowed during this process. Please make sure not to lift the vehicle body with the excavator bucket when placing it to the ground. Extend the stick outward to the limit, with the bucket tip touching the ground, and use a TK rover to measure the coordinates of the left bucket tip. Keep the excavator still. Input the coordinates of M1 and click the Collect button. Then bring the stick close to the cab as possible, with the tip of the bucket touching the ground, and use a TK to measure the coordinates of the left bucket tip. Keep the excavator still. Input the coordinates of M2 and click the Collect button. When the heading difference between M1 and M2 is within 0.2, the calibration error should be about 3 to 4 centimeters, and the larger the heading angle difference half, the greater the error will be. After input and collection are completed, click the calibration button. The system will provide the calibration results. When the residuals of M1 and M2 are within 3 centimeters, it indicates that the calibration accuracy is good enough to pass. Click the Confirm button, then click Complete. 4. Accuracy check. Rotate the excavator. Adjust the boom and stick to different postures. Measure coordinates and compare with the TX73 software. If the error in the northeast height is within 3 centimeters, it indicates that the calibration has been successfully completed. Please use at least 3 different postures bucket locations around the machine for coordinate accuracy verification. 5. Backup calibration settings. After the verification is completed, backup calibration settings in the calibration menu. At this point, the calibration of the TX73 excavator 3D guidance system is complete.